Okay, and with that, it is 7:30 a.m. Pacific, and so I am feeling very awake thanks to my latte. So today the plan is to be working on adding some more PMML support into Apache Spark. I'm also open to doing other things if there are requests, and so I'll look at the chat in sort of both YouTube and Twitch. And if you have any requests or if you have any questions, please do feel free to ask. It's a lot more interesting when there are other people involved besides just myself. But that being said, I'm used to writing a lot of code just by myself, so it's totally fine. So yeah, looks like I have the chat up. So let's go ahead and switch. So here we can see that earlier in the day I was at the Scala spree and I was actually working on SBT related things. Actually not super sure that worked. It did work, yay! And there was some log level stuff. Let's go ahead and switch back into the Spark project. And let's start by refreshing ourselves onto what the current PMML support is. Actually, let's start with what PMML is. That's a good point. So PMML is a Predictive Model Markup Language, is what the acronym stands for. But we can just think of it as a model export format that is common between many systems. For example, here's a list of some of the exports and some of the people who are able to provide, consume the models and serve the results. And so today we're gonna look at adding, so I'm gonna try adding support for a thing which we haven't had support for before in Spark, rather than just doing support based off of our existing legacy Spark ML lib. And so essentially there's two different Spark machine learning libraries. And we'll take a look at that really quickly as soon as this finishes resolving the host. It's not a great sign. Okay, maybe, okay. So if we see here, there's MLlib machine learning. We can go in here and we can see that there's a new data frame based API and it is now the primary API. That being said, the data frame API in its released version does not currently have PMML support at all. If you've watched some of the earlier live streams, you've seen the initial adding of PMML support to Spark and also the Python support. But we want to go beyond just sort of the built-in things, because part of the appeal of Spark ML pipelines is that we can put a bunch of things together. And that's really cool because it tends to happen that we need a bunch of different things together to make a machine learning model. We tend to have to normalize our data or do something with it. And so I'm going to try adding support for a normalizer. And we'll see how well this works out. I'm not a PMML expert by any sense of the imagination. So I spend a lot of time in Spark, but PMML not so much. So this is a little bit out there because the previous times have just been getting the existing implementations to work with our new APIs. So we'll see if I manage to make it work, and that'll be awesome. Or if I don't, we'll make some progress, and then I will bug someone else who's maybe more familiar with PMML. Taste that latte. Okay. So if we go into MLlib, src, main, Scala, org, Apache Spark, and we go into, these are the two different libraries. We're going to go into ML. And we're going to look at some of the feature tools. And the simple one that I can think of is the min-max scaler. Does this take... Let's actually look at the standard scaler. because I think the standard scalar more closely matches one of the PMML scalars operations. And so whether to center data with a mean before scaling. So let's look at the model, because that was going to be the part that we're going to have export for. So it looks like the model takes in a mean, takes in a standard deviation and mean, both in vector forms, and it has an input column, which is the vector that it is scaling, and an output column. Is the input column a vector? Probably. We can go up and take a quick check and see if the input column is actually, yeah, so, right, so the input column is a vector. And so that more or less makes sense, kind of matches what we would expect. Let's go ahead and get started. So let's, the first thing, oh, actually, does this not have any save model right now? That, oh, okay, it does extend ML writable. Okay, that's cool. So that's good. So we will change this from ML writable to the general ML writable and start the refactoring, and then we'll start figuring out how to write the PMML. Because the refactoring part we should at least be able to do and get it to compile. So we can make some headway, even if it's not that much. So I'm going to switch into this split screen view. We're going to go up, and I think I added it to clustering k-means, I think. Yay, cool. That looks solid. So we do have it here, and we'll essentially start following this pattern. So this becomes a general ML writable. Our ML writer is, I don't think we override def right in that case. Def right, no, we do, okay. That's fine. And the next thing that we have to change is we're gonna go find the writer. Yeah, so we're gonna have to, we don't have to. We're gonna move this out and make it discoverable. And it's in the same way, extends ML writer. And we make it a private class, so that's fine. Private class. Actually, I should probably just do that. And then we'll paste it over here, switch this to private, and then we go ahead and we indent region. And this isn't PMML, this is Spark's internal format. But because we now want to support multiple formats, we have to refactor it to allow it to discover the different writers that are accessible. And so we go ahead, swap that in, or actually wait, how long is this line? Yeah, 112. New line. Extends ML writer format, yeah, with ML format registry. And so the other thing that we do is this is the internal format, and the stage name is dot feature dot standard scalar model. Save import. And so this is sort of our first checkpoint. Okay, actually, we also have to add it to the service info file because we use this kind of esoteric Java discovery system, which is what is also used in the data frame API to allow it to be extensible outside of Spark. So if, for example, you wanted to provide support for exporting like k-means in a different format which we hadn't thought of or just haven't bothered to integrate, you could offer that as a package without having to like access our internals. So is it src main resources meta inf services? Cool. And so these are all of our services. Sorry, these are all of the writers. And so we have a new writer. Oh, actually, this should probably be in, well, whatever. org.apache.spark.ml.feature. What is this thing called? Internal standard scalar writer. And so at this point, the test should pass. And so that's a good checkpoint whenever I get to a place where my tests should pass, that I should probably actually test them. Okay, the Kubernetes compilation is failing for reasons which I probably don't really care about, at least not today. Let's go git diff. Don't have anything in Kubernetes. That is a thing that I should investigate later because I am working with some of the people on the Kubernetes PySpark PR, and so that compilation failure is a little bit worrying, but we don't need it to test our machine learning stuff. So I'm going to go ahead and do an mllib test compile. Normally I'm pretty lazy and I just tend to run all of the tests, but in the ML space, there's a lot of them. And so I kind of don't want to do that because some of them can take a while. So let's go feature. Okay, cool. And so once it's done doing its test compile, I'll do a test only here. Oh, that's weird. Standard scalar, that's not good. Screwed up. Probably 7134. What did I, did I just, no. 7134. I don't, oh, cool, okay. Cool. Oh, yeah. Forgot to get rid of that. Okay. Cool. We'll run it again in just a second. Yeehaw. So today I'm eating some currywurst fries because I'm in Berlin. I'm drinking some mate because I'm also in Berlin. Yeah, the hotel Wi-Fi is actually surprisingly good. It's like 100 megs up, so hopefully it's pretty solid. I was tempted to go to the conference venue and just kind of like find a place to hide there to do this stream, but I wasn't super sure conference Wi-Fi can be a little bit touch and go, so I figured I'd come back to the hotel and then I can also take a nap after I'm done this. Man, this compilation is kind of slow, and by kind of slow I mean really slow. Oh, sorry everyone, you got to watch the really exciting slow compilation. And this is, I mean, relatedly, this is kind of one of the things which I feel bad about in Spark, but really don't have the time to tackle, is that we have a lot of warning errors, and I'm pretty much just warning blind at this point. And that's not good, because some of these warnings could actually be kind of important. So if you're ever like looking for something to just do in Spark, one of the options is you can come and just start fixing compiler warnings. At the Scala spree that I was just at, someone was doing that inside of SBT. They were fixing compiler warnings of SBT itself, so that hopefully, you know, when we actually do encounter something important, we actually, you know, notice it. That being said, this is really slow. Oh God. This would be a great time if anyone had questions to jump in with questions to distract me from the incredibly slow compilation process. Or not. Okay, that's fine too. Oh, actually, I haven't checked to make sure that people can actually hear me, which I probably should have done. It looks like it's probably working, but we're gonna bump it up a little bit, and hopefully this recording will be a little better. But yeah, if anyone has questions, now is a great time to ask them. Otherwise, I will go and learn about PMML some more while we're waiting for the compilation to happen. Yeah. So one of the things that we have to do, so I'm not going to do it in this PR, but normally, for example, you probably wouldn't want to just use a standard scalar transformer. So one of the things which we'll have to tackle after this PR, where we add support for exporting this, is figuring out how we want to do exporting 2 stages to PMML, or 3, or essentially 4 altogether into one PMML model. And it's cool. There we go. Yeah. Rule feature. It's upgraded. Yeah. Okay, the output element allows for post-processing of output fields, i.e. transforming raw predicted values. Yeah. Probably not what we want to do. Similarly, yeah. I mean, that is a thing that some people might want to do. For example, if we do category indexing, there's a good chance that in your actual production pipeline, you're going to want to take the category indexes and turn them into actual category values. Yeah. Okay, transform value is okay in all of these. I wonder, is there like a chaining PMML models? Because like if we can just concatenate them, yeah, it's not going to happen. So essentially what we're going to have to do later on is we're going to have to probably pass an XML constructing object around between them, and that's going to be a little rough. Cool. So it is not done just yet. Cool. Scala style on compile failed. Okay, cool. Let's recompile mllib now that we fixed that. Hopefully the incremental compiler will have mercy on us and cache more things than it did last time. Okay, cool. Oh, lovely. Line 196. What did we do in the k-means version of this? Oh, yeah, okay. So, need to change this part. Okay, so that's cool. val instance equals stage.as instance of standard scalar. Okay, cool. And so we just changed the signature to match, so hopefully that's good. Actually, do I use the Spark context here? Yeah, I do with the default params writer. Okay. Oh, standard scalar model. Huh. Yeah. Oops. Didn't actually mean to change anything in k-means. Scala. Cool. Oh, no, that's, sorry. We want to import mutables so we can reference the mutable map. Oh, it sounds like it's raining. Okay, so I guess I will not ride a scooter to the venue after this is done. I've had a lot of fun riding some scooters. Compile again, drink more mate. Lovely. Okay. Do a test compile. Actually, the next thing while that's running that I want to look at is the standard scalar suite to see if it's got any, yeah, so it has the default read-write test. So that's good. So if we run this suite, it will indeed test that we haven't broken Spark's internal model export on our way to add PMML support. I guess while this is running, we might as well go and take a look at how, for example, k-means does its output. K-means model, is there a writer in here? Or, no, sorry, PMML exportable. Yeah, I remember that the design of that was confusing to me because I was lazy. So, PMML model export factory. I don't really like this one because then it's closed and other people can't add more things to it. Because I mean, other people can, but they have to add them inside of Spark. I'm lazy, so I don't want to do that. Okay. Yeah, that's going to be non-trivial, right? So eventually, we're gonna want to pass around some of these things to allow them to be composable. And it's going to be a non-trivial separate PR, which we'll look at. Okay, cool. Compiled. So we're going to go test only org Apache Spark ML features standard scalar suite. Okay. If this works, it's a good point to make a commit because then, you know, it's a point where we know we haven't screwed anything up too badly, which is always nice. I personally like having lots of small commits along the way that I can come back to. And it's kind of nice in the Spark project because everything gets squashed down to a single commit anyways. It doesn't really super matter. Now let's turn this light on and see if it's any better. Ooh, cool. It looks like I probably did screw something up. So that is a good discovery. Let's figure out what I screwed up. Internal standard scalar writer not found. Interesting. Let's go look at standard scalar. So, okay, yeah, it has to not be private. It's private Spark, maybe? Oh! Damn it, this needs to be internal. Damn it. Okay, whatever. Okay, Scala style exceeds 100 characters. Lovely. So let me just go ahead. I mean, I appreciate Scala style, but sometimes when I'm just hacking on my PRs, I really don't appreciate Scala style. But it's probably better than like going in and fixing my style issues later, so I leave it on because some things are better for me, even if I don't want to do them. Cool. So we can start. Oh, right, and before we make the commit, normally make a branch. Before I make a branch, normally make a JIRA. So, internal standard scalar writer. Yeah, I probably just didn't. Oh, I said model writer. Yeah. Cool. That's great. So let's go ahead and file a Spark JIRA. This is useful to track the work and also make sure that we're not stepping on anyone's toes. So PMML scalar. Cool. Don't see it showing up anywhere. That's a good sign. So create issue. Add support for export for the standard scalar stage. Priority is going to be trivial because it's not really a rush. Spark ML, no, okay, ML, cool. Let's say 240. We're not going to put a fixed version in yet because I don't know when. And same thing for target. In anticipation of supporting exporting multiple stages together to PMML, it would be good to support one of the common feature preparation stages, standard scalar. Cool. We hit create. Assign to me. Leave a comment. I'm going to work on this one. And this is just so that other people don't waste their time working on the same PR that I'm working on. So that's cool. God damn it, the tests still don't pass. Although it looks could not be instantiated. Oh, cool. Standard. So then maybe this will actually all fit on one line. Damn it, one character over. Alright. Once more, for good measure. Oh. Most likely the result of this is going to end up being a work in progress PR, but I'm hoping that we can get to the point where we actually have something being exported even if we're not super sure it's the right thing. And then we can share it with someone who cares about PMML a lot more, or maybe not cares, but has more experience with. I'm not completely sure if exporting just a transformer on its own is actually valid PMML, which I guess we'll find out at some point. Cool. It's kind of slow, but it's looking good. Read to write test passed. Okay, great. So then we probably didn't screw it up, and that's super exciting. Okay. Branch, git checkout -b. I'm going to go back into here. I like to put the JIRA numbers in my branch names. It makes it easier when I go to make pull requests, but also a description so I can find them. Add support for PMML export of standard scalar stage. Cool. And works better if I spell checkout correctly. I love that I can press Control-C to swap two characters next to each other. Super convenient. Okay, refactor standard scalar to use general ML writer. And so that's good. It gives us a point where, yep, the old functionality still works. Yay! And we're closer to being able to add our own fun thing. So up next is going to be doing PMML. We're going to switch this from internal standard scalar model writer to PMML standard scalar model writer. We'll change the format name to PMML, and let me get rid of this part. Actually, and so let's go key means PMML export. This writer takes PMML.add models clustering. That's weird. Oh. Okay. That's cool, I guess, or something. Yeah, we can deal with the right path when we get there. So, first things first, we need the PMML imports. There's a chance this might actually be better in its own file. For now, we'll just put it in the same one, just as a place to start. And yeah, we can go from there. So that's cool. The first thing that we want to do is so let's go look at PMML model export factory. That's not okay. PMML model export.scala. Yeah, cool. So that's a start. So if this is val PMML, headers. We're definitely going to want to refactor some of this later, but this is an okay start. And we'll switch this to Apache Spark ML. That gives us us a PMML object that we can work on. So k-means. Actually, do we support anything close to this? No, we don't. Well, yeah, no, we really don't. Okay. So we need a new data dictionary. And let's go take a look at how to make this. Do I actually need... I want a transformation dictionary. Is that a thing? New transformation dictionary. What do we do with the data dictionary? Yeah, we should also have a data dictionary. Okay, so transformation dictionary. Let's do this in order. Construct our input fields, and so in this case, for I 0 until internal dot. It's going to be like something that size. What is it? It's the load path, not the one I want. Instance.mean. No. Instance.mean. Yeah, sure. Actually, really, what I want to do is instance.mean. Oh wait, no, it's a whatever. We'll do it with this for loop because instance.mean.size. Because we're mutating everywhere, so there's no real point. Well, I mean there is, but so this assumes that the input is continuous. Cool. Which makes sense because we're a scalar, so input should definitely be continuous. I don't think we need a mining schema. So let's go look at a transformation dictionary. Transformation dictionaries have derived fields with an op type and a norm continuous fields. Well, let's start off with seeing if this still compiles. MLlib compile. Yeehaw. 0 until instance mean size transformation dictionary. Well, ooh, not so happy. Okay, simple date format, all kinds of sadness. No, PML model export. Yeah. So in this case, we were just missing some imports. So that's what we're going to fix. Standard scalar line 155. Oh, no, we are in that 155. Standard scalar. Oh, crap. that's not good. Did I put in 2 of those? PMML standard scalar model writer. Wait, what? Oh, reference to row is ambiguous. God damn it. Fudge. Well, for dev, and I'm not saying that we can actually get away with this, but while we're developing, I'm just going to go ahead and move this. Oh, except we'll see if Scala style lets me get away with this. And if it doesn't, I'll factor it into a separate file. Yeah, looking good. Okay. Data dictionary. Okay, so it says fields I. K-means model. K-means PMML model export. Oh, okay. Well, what does it do with fields? I mean, we don't really need that, do we? Because if I just do val field, this is just a field name. Okay. Yeah. Cool. Oh, it's not add fields. It's oh, it is add. Yeah, it's add data fields. Okay. Yeah, because we reference it there. Huh. In that case, maybe I do actually want to keep it around. Well, we'll change it if we have to. Okay, so transformation dictionary, that looks cool. Let's go transformation dictionary dot let's val derived field. Well, kind of wish I had enzyme, so let's try turning it on. Enzyme. Oh, do I not have? I don't have enzyme set up globally because I reinstalled this machine. Oh, let's go look up PMML transformation dictionary Java doc. Java doc. This looks close. Java doc extreme for those extreme Java docs or something. I don't know. It's random ads. Oh, not so random ads. I'll be talking at Strata London, and anyways, okay. So wait, what am I looking for? Transformation dictionary. Transformation dictionary. Yeah. Ooh. Okay, get derived fields. Add defined functions. Oh! That's my alarm to remind me to take my afternoon medication, so I'll do that. What's the difference between a derived field and a derived function? Let's figure that out together. Yeah. Oh, this is define function. The other one is derived field. Okay, that makes a little more sense conceivably. Yeah, in this case, I think we can just do derived field. Op type, data type. Now, is that actually all? What does op type support? Maybe I can't use derived field and I have to use derived function. Oh, all continuous, ordinal. Let's go back to this example. This is a derived field. Data type, op type is continuous. Doesn't show continuous in here. Oh, wait, yeah, here we go. Wait, okay. Op type is continuous, and then inside of the derived field. No, so yeah, inside of the derived field, what else does it contain? Add extensions and add intervals. So this would probably be an extension. Let's take a look. These getters and setters are just really not at all useful. I don't know if this is an extension or an interval or a value. No. Oh, fucking goddamn. Well, whatever. Let's get started. So, derived field. There's actually a pretty close mapping. Org, or at least it looks like there's a pretty close mapping. So let's figure out org JPMML. No, well, is that what I want? Oh no, this is. Oh, actually, this is continuous. Is that? I don't want the uses of the class. I want to find the definition of the class. Let's see what it extends to. Java doc norm continuous. That's not so happy. Okay, well. No, this is JPML, not where we want to go. Here we go. Well, this is just uses of the class. Oh, but okay. If I click on it, it is an expression. So op type can be continuous, which is fine. Value has extensions, get extensions. Yeah, okay, so we would add this as an expression. Cool. Okay, so we've got a pretty okay idea as to what we need to do now. for kind of flexible version of the word. So val, if this is a, go back up to the top, so transformation dictionary, so val derived field, that's new, ooh, it's new. Yeah. All of these setters make me a little anxious. I mean, not anxious, but just maybe curious. I don't know. So this is a derived field, and on it we want to add expression. No, I can add I can get expression. Well, we know what the op type is. The op type is continuous. So let's put that in here. So op type dot continuous data type dot double. Okay. But it's not. So I have a derived field, and I can add an extension and a value, and I can get my expressions, but I can't set my expression? Yeah, no, I can. Okay. It's called set rather than add. Okay. Dot set expressions, set expression. That's fine. So then our expression is a norm continuous. So new norm continuous. Okay, so this is the part where we actually do want the field names. So fields I, which is fine, and a list of linear norms. So let's actually move that up. Cool. Just make things a little, just a little cleaner. Okay. Is it a linear norm? This is a linear. Linear norm. Okay. So we specify. So this isn't quite standard scalar because we might want to subtract a thing. So this might be min-max scalar. Are there other types of norms that I can use though? Is there one which gives me what I want? Linear norm directly extends PMML object, which is not really what I want. Okay, so op type, yeah. I one of these was expression, right? Derived field. Set expressions. Takes type, or set expression takes type expression. Let's go look at who implements this. Oh yeah, cool. There's some other norms. Okay, there we go. Norm continuous, norm discrete. So this is going to be oh wait, no, this is doesn't support. Does it support subtracting? Linear norms is of type linear norm, which almost what I want, but not quite. This is a min-max. Let's go see if the min-max scalar looks like this. Although that would be really annoying. Let's go look in standard scalar. Yeah. Let's go look at our transform function. Oh, what? This actually still goes into. That's interesting to do. We should actually make sure there's a JIRA for this while we're here. Make the transformer natively in ML framework to avoid extra conversion, because there is no particular reason to do this. So standard scalar let's scroll through these issues really quickly and make sure that none of them okay. And status equals open, or really anything that isn't resolved. Cool. Okay, let's go ahead and create the issue for that. This would actually be a great starter issue. So trivial ML make standard scalar work without legacy ML lib 240. Is there a labels section? I'm more than happy to shepherd this. Let's make it up. Okay. Or JIRA. Currently, standard scalar converts Spark ML vectors to ML lib vectors during prediction. Oh, cool. So there's a question: am I using Apache Server? And so this is Apache Spark. And the JIRA that I'm connected to is the general Apache JIRA. And so this JIRA tracks issues for all of the different Apache projects. Hopefully, well, not all, but many. During prediction, probably we should skip that step. Okay, cool. That is that. We're going to create the issue. I'm going to go through and actually tag it as a starter issue. And if anyone who's watching, or really just anyone that you know of, is interested in getting started with Spark ML, I think this is a really good starter issue because there's sort of existing code that shows you the path to go down. And so I'm going to go ahead and actually, while we're in this, just do yeah, because there's no no particular reason we should be doing that. So let's go find the old standard scalar, mllib feature standard scalar. Yeah. Doesn't let us subtract the mean though, so that's frustrating. PMML subtract mean. I don't know. Maybe we'll get lucky. Well, this is PMML into PFA, which is another format which we could also look at supporting. Maybe there'll be subtract. Oh, cool. No. So, okay, maybe we actually don't want a transform model, and instead we want to use a baseline model. Actually, this is the target that we should be going. Damn it. Okay, well, that's life. I think this is the target that we want to be going. Well, actually, is it? I don't actually want. Actually, yeah. Wait, do we? Okay, values. Wait, is this actually subtracting the mean? Where does it? Oh. Okay. If with mean, then we do this. Otherwise, we do that. Okay. So that's cool. Go back here to our happy adventure. We keep our data dictionary as is, except instead of a transformation dictionary, baseline model. Oh, okay. We also are going to switch this. Yeah. Fields. Okay. New baseline model. Okay, cool. Let me go back to PMML. Exportable. We go export PMML model export, and this had. Oh no, not quite what I want. So we'll clean this up later, but we want to make some progress, hopefully. So then we have a baseline model. Then for each field, we get the field, We're not doing the derived field or the transform dictionary anymore. So let's go find baseline model inside of the PMML Java doc. Package baseline model. Cool. Baseline model implements has extensions, of course. Oh, cool, and it takes a test distributions as a parameter. So we will instead probably make a list of test distributions. So val test distributions equals new test distributions, yeah. And it only takes one. Okay, so we actually need to make many instances of baseline model. Does that sound right? That sounds right. Okay. Or, I mean, it sounds sort of right. Cool. Now I probably need that mining schema thing. So mining schema dot set. Add mining fields. Oh, god damn it. I'm gonna do it this way just because I prefer to read it this way. New mining fields I dot set usage type field usage type dot active. Yay, cool. Okay, that looks right. Test distributions. Let's go look at test distributions. Yeah. Oh, actually, so we can probably fields of I. Okay, yeah. Sorry, field. Stop calling into that same array. Baseline statistic type and baseline. Yay. Okay. Stat type and baseline. Cool. Val baseline and val stat type. Yeah. Yay! Do I want scalar product? No, I want z value, I think. Yeah, okay. Cool. Baseline is yeah. Oh. I'm reasonably optimistic. Yeah, and there we go. Now's the part where we start to get into. And by I mean the parts that don't work the way I want them to. Okay. New baseline as it. Okay, yeah. Let's go back into our friend's example. Cool. And so in this case, Gaussian distribution, mean 1, variance 4. So dot. Ooh, why is my computer all of a sudden super slow? That's weird. Although it has, yeah, Alt-Tab stopped working. That's weird. Oh, it is. It's just super slow. Okay. I mean, it's probably Chrome or my live streaming software or something. I chose a laptop that was light to carry, which I'm regretting now. Let's go find Gaussian distribution inside of the package. Gaussian distribution extends continuous distribution, which extends distribution. Okay. So let's go val distribution equals new Gaussian distribution. Instance dot mean dot instance dot mean I and instance dot std I. Cool. That's exciting. All I have to do is figure out how to put that into not op type. Baseline. So baseline, oh cool, get continuous distribution, so I imagine set continuous distribution. Distribution, cool. Let's find out all the mistakes that I've made in the past few minutes. It's gone too long without running a compile. Oh yeah, okay. No, that's not field name, that's actually field. Oh, yeah, okay. New mining. New mining fields? Oh, it's new mining field. Cool. Baseline model is not found. That's weird. Oh, wait. Yeah, okay. Wait. So we make... We make a baseline, which is... It extends PMML object. The following schema fragment is contained within this class. Okay. So that's actually probably what I wanted. No. So I make a Gaussian distribution. I make a baseline. I put the Gaussian distribution inside of the baseline. I put the baseline inside of the test distributions, and then I make a, I camel case baseline. Whoops. Yeah. Cool. I imagine that I misspelled continuous. Set usage type is not a member of mining schema. Weird. Because it... Oh, yeah, okay. Wait, really? Mining schema dot add mining schema dot add mining fields. Oh. Okay, that was annoyingly indented, I believe would be the expression. Do these two fit on the same line so that I can... Cool. Because then I can read it the way that my brain would expect. Oh, yeah, okay. mismatch parentheses. Yeah. Cool. It's getting close. So close. Okay. Set continuous distribution. I almost certainly misspelled the word continuous because I'm very classy. Okay. Unless it's changed, but it's fine. Or unless it's distributions or something. No, I just misspelled continuous. An extra U for good measure. So, cool. Okay, so that's just complaining about a in progress key means. Whatever. There should be no changes there. Actually, there should be no changes there. Let me run git diff to make sure. Yeah, there's no changes in k-means. Actually, I ran into that Emacs thing while I was hanging out with one of the SBT people. We talked about if we wanted to try and handle that natively inside of SBT. Cool, compiles. It's a good start. Although I do have to figure out how to add this. So it's baseline model has, this is baseline, oh, this is baseline. Oh, okay, cool. And so then baseline model almost certainly takes a baseline model. Yeah, here we go. Mining function type, mining schema, and test distributions. Yay! Cool. So new baseline model takes in a mining schema. Oh, it takes in a mining function type. Mining function type. Mining schema. And it takes the test distributions. So we are missing the mining function type. Let's go find out. It is an enum. Function type. This is probably regression. Let's do this for now, and we'll see. It gives us a place to start. Cool. Then we have our baseline model. Then we need to add our baseline model to a thing. I think which is fine. Okay, cool. PMML.add models, clustering model. Add models, baseline model. Lovely. It's pretty close to what we want. Still compiles, hopefully. And then we have a PMML object, which is in theory ready for export. That being said, actually exporting it is another matter. And so not that one's not so good. We should make some common traits to handle this. PMML model export is the type. Key means PMML model export. Okay. So that's all well and good. I have a PMML object, and I want to turn it into a string and save it somewhere, which is fine. Yeah. Oh, okay. Scala style error. What was it? White space at end of line 275. Yeah, 257, but that's because we're working on that line. That's fine. So we're doing okay. Oh, G to update. Yeah, no, there's actually nothing there, but that's fine. I do want to figure out where we're going to put this. Let's go and take a look. Display name. It's the root PMML object. Is there like a toString or something on it? That's what we actually want to do. It's toString, but I don't actually know if that gives me the string I want. Okay, let's go find. Let's go back into the k-means or whatever it is. K-means.scala. This is the old one. So PMML k-means. So yes, we just ask parent model to save it to PMML. So let's go find the old k-means, mllib, clustering, k-means.scala to PMML. Okay, no. This was k-means model to PMML. No, okay. Since PMML exportable, PMML exportable has to PMML, which takes a stream result and saves it somewhere. Here we go. This is the magic incantation, which is just really kind of weird as a way to do things. Right. I don't get this stream result thing, but if we look here, what happens is 2 PMML. So we'll make that happen. So we've got our PMML object, val, okay, sc.parallelize array PMML1 save as text file path. Except this is probably the 2 PMML, which takes a string. So we go ahead, val writer equals new string writer. And then we go ahead and we take PMML dot val stream result equals new stream result writer, and then PMML dot so actually we go ahead and we go jaxbutil. Man, yeah, this definitely belongs in a helper function similar to this one, but stream result yes, text is equal, yeah, because that's the one where we give back a string. Yeah, is writer.toString, and then we take PM. This is okay. To do, hold on. Vector into a common base util. Yeah. Constructor input fields. Oh, there's probably also a bunch of things in there. I mean, yeah, that's fine. This part can't get factored out super easily, I don't think. The data fields we're gonna have to figure out what to do with. Holden doctored this out somewhere. Common and allow chaining. Cool. So start. Let's compile it. We'll make it. Yeah. Yeah, we'll compile it. Oh, and then we're done. String writer. Cool. Oh yeah, okay. Cool. We also definitely want that. Oh, okay, yeah. Ugh. Yeah. We'll fix that later. Wait, can we... Wait. There's a thing I need to check with licensing really quickly. Let's take a look. Cool. Org JPMML license. What license is this? Okay, cool. This looks like a fine license. I mean, I don't know. It's already in the project. I just wanted to check because for some reason in my head, there was some issues around using JPMML. This could actually be method friendly. This could be a nicer way of doing this. But I'm not going to rewrite the code now. It's been like a while. I just want to get this part in. Okay. Pardon me. I'm going to go wash my hands really quickly. Okay. So this is progress. Oh, is it just okay? Oof. Okay, yeah. So we want to move this import over. Or, okay, I think org Apache stands on its own. There we go. Stream result is also missing. Java XML transform stream result. Whoa. Old school. Oh, this is Java X XML. Cool. Okay. I think it wants these two to go together, so that's fine. Oh, cool. I set up a web server on Windows, but when I open it, a message pops up showing a MSCDLL, some sort of thing, fails in execution. Yeah, that is probably outside of my wheelhouse. I work mostly on data processing, and so the Apache projects encompass a large variety of things. And so there is the Apache web server, which might be what a lot of people think of when they think of Apache, but there's more than that. There's a few hundred Apache projects, and so I don't know how to fix that. I'm sorry. But the good news is this compiles. Probably it doesn't work, but it compiles. We've made some progress, and I'm going to call it a day for today. We've got started on this JIRA, and we'll initial start on adding support for exporting standard scalar to PMML. And this is just a start. I'm kind of lazy. We'll do some more work on this. I'm going to push it, and we'll make it. So I'm going to make it a work in progress pull request, just in case anyone who's been watching today wants to go take a look. So thanks everyone for joining me. We're going to call it a day. I don't know if I'm going to have time to do my normal live stream code reviews this week. If I do, it'll probably be on Friday, but I think that might just get pushed to next week. So thank you all for joining me. Have a wonderful week. And yeah, if you're in Berlin, I hope to see you at Scala Days Berlin. Let's go into this thing and click end.